Hi Matrix, I hope you've all had a break. Let's put away those cell phones now. You can chat to the girlfriends and the boyfriends later again. Let us get down to some science. Right, the next question, if we have a look at it, it says to us that we have a simplified sketch below which shows the principle of operation of an alternating current generator. Right. The first thing, I think this examiner was very, very nice because I'm not quite sure if an examiner would have told you all of this. As an examiner, I actually would have asked you, what is this? Right. And then you would have gone and you would have had a look and you would have seen there's no power source. So you then would have told me it's a generator. And then you would have gone and looked and you would have seen that you had slip rings. So you would have told me then it was an AC generator. Okay, but in this case now, he was nice and he gave us all that information. Now they say to us, name the parts labeled A and B respectively. Right, this is not very clear, although A we can see clearly goes here, and B actually goes to over there. Right, A, I think we can immediately all say that that is the slip ring. Okay, now B, I haven't actually discussed with you, and let's quickly see in our PowerPoint if we can find a picture of this. Yes, there we go. Right, this isn't a motor though, still the same. Can you see that here we have what we call brushes? Right, have a look. There, brush, it says brush there, and let's carry on. Right, you can't see them very clearly here, but if you have a look, you will see that there they are. Those are the brushes. And what the brushes do, people, is they ensure that there is contact between the slip ring and the conductor. Okay, so that is basically what the brushes do. They make sure that there's contact and that the electricity is then actually conducted. Okay, so in this case, you would have said that they are slip rings and brushes. Right, now the next question is, the next question says to me, in which direction does segment PQ of the coil have to be rotated in order to cause the current direction as shown in the diagram? Right, let's just quickly go back. In which direction does segment PQ, so let's quickly look, here's PQ, right, have to rotate in order to cause the current direction as shown in the diagram? Write down only clockwise or anti-clockwise. And once again, can you see what I've said all along here, Matrix? We're looking at one mark. Okay, now, what are you going to use? Left or right? Left hand or right hand? I wonder, right hand. Why right hand? Because this is not a motor. This is a generator. Okay? Quite important. Quite important. So we've got to get our right hand. And if you can remember, I wrote on my right hand here. Let's quickly see. There's my right hand. Okay? This is my north. So my knuckles must go like that. Do you agree with me? Okay? There's north and south. Now my current must go in that direction. Do you agree with me? Because that's the direction that it is pointing in. Okay. Right. Am I busy with my right hand rule? Let's just check. And according to this, I just want to check. What am I doing wrong? Right. And according to this, it should be clockwise. Right. Why? Because this is now going to go up. Okay. Let's just double check. B is north to south, Q is in that direction, therefore this must be going up, and it should be going clockwise. Right, let's just check with the other hand quickly, or with the same hand, but let's check. So what happens in this case now? The current's going to be coming to me, north to south. Remember, my knuckles must point in the right direction. So it's going to be going down, yes. So according to me, yeah, it would definitely be going clockwise. Right, now they say here to me, write down two changes that can be brought to improve the output of the generator. Okay, right, so number one, it's very similar to the one we had just now with a motor. So the first thing we could have done is increase the number of coils. Increase the number of coils. Remember, we had the same question just now with a motor, right? Then we could also increase the magnets. Okay. Now, in this case, ladies and gentlemen, we can't increase the current because that is what we want. Okay? So we've got to think of something else we can do. Right, we can increase the speed of the rotation. In other words, remember what is happening. This thing's being rotated. In electricity power stations, it's being rotated by steam. Okay? So we can increase the speed of the rotation. Speed of rotation. And then the other thing that we can do is we can use a horseshoe magnet. Right. So those are the things that we can do. Right. Now, what changes must be made to the AC generator to make it function as a DC motor? Okay. So, the very first thing, what are we doing? We're going from a generator to a motor. Right. Remember, a generator does not have a power source, but a motor does have a power source. So number one, we would need a power source or a power supply. And then we are going from AC to DC. And I'm sure you can remember, in AC we have slip rings, but in DC we have split rings. Right, so what changes must be made? Number one, we would use split rings. And then number two, we would have to have a power source. For example, a battery. Right, got that? Okay, now the next question. The waveform on the following page is a graphical representation of the variation of voltage versus time for alternating current. Okay, right, so what have they done over here? They have given us a graph. Now let's look what graph they've given us. Right, immediately when you saw this graph, immediately you should have made a note to self. Self, this is alternating current. Okay, why do I know it's alternating current? Well, because it looks very similar to a sine graph. And the negative means the changing of direction. Right, now they say to us, and please people, this you must learn, please, 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 please. They ask this every year. And then people don't learn it, and it's 2 marks definite. Okay? They say to us, explain the advantage of using alternating current in power stations. Right. Remember, we have already discussed this very briefly, but the first thing that we need to say is that in AC, alternating current can be stepped up or down by using a transformer. Transformer, right? And then we can say this means, therefore, electric current can be transmitted over long distances, at low current and high voltage. And why do we use this? To minimize loss of energy or energy loss.